Thank you for having me, and I really appreciate. I love Portland, at least my wife does. I've never been to Portland, so I'm good to be with you virtually with you. Yeah, a little bit about myself. I'm a data analytics engineer, and right before the presentation here, I was chatting with Greg that I kind of wear all the hats in my company. So I work at Cree Lighting. We are one of the largest LED lighting manufacturers, lighting fixture manufacturers in the world, located in Wisconsin. My background is actually in mechanical engineering. I was a research engineer. I got my master's in mechanical engineering. Did that for about 10 years or so, and always worked with data, and kind of got into business analytics, data analytics, and now data science. So kind of enjoying it right now. I'm an Azure certified data scientist, support DP 100 and DA 100, and I blog at powerbi.com. And follow me on Twitter at powerbi. And yeah, I'm pretty active on Twitter, so follow me if you're interested in Power BI and especially the ML AI side of Power BI and Azure ML.
Sandeep's pretty active on Twitter, I'll tell you that. So
yeah. Okay, so the agenda for today is we're going to keep it very simple. It's all demo, so hopefully the demo gods will cooperate with me today. But we'll first look at the licensing side of Power BI AutoML, and who can use it. If you are interested in it, how can get a hold of it? What exactly is AutoML? We'll understand the mechanics behind it. So we won't just look at the steps involved, but we'll look at what is ML from a 30,000 foot level, and then how to create these models, these machine learning models. In case you're wondering what is ML in AutoML, well, it is machine learning, right? And with machine learning, we are creating models. So how do we create these models that are business focused, generalizable, and I'll explain what that means, are interpretable, manageable? What does the overall process looks like? So if you are somebody who has not worked with machine learning before, does not have prior experience in it, we'll go over that process. Or if you work with somebody, maybe a data scientist or a team of data scientists, the session will also help you understand the process from their point of view. So you can help them in creating these machine learning models. And at the same time, if you are a consumer of machine learning models, my hope is that you will also get something out of this presentation so that you can ask better questions, you can get better insights as to how a model was created and what are the kind of things that you should watch out for when somebody says machine learning. So Power BI AutoML, the licensing requirements, it's a premium capacity license. You have to have either premium capacity or PPU, which is premium per user, which was launched, I want to say maybe late last year or so. So it's been a few months that we've had PPU. PPU is $10 on top of your pro license. So the overall cost is $20. Right now, what I'm going to show you is using my own personal PPU capacity, which costs me $20, $20 a month, and I can turn it off when I don't want it and turn it back on when I do want to use it. Or you can, if you already have an embedded capacity or embedded license, then you can use AutoML too. It's not available for Pro. So anything that you develop, if you want to develop a machine learning model, you have to use a premium capacity. And the model that you generate from AutoML, if you want to consume that, it has to be in a premium capacity. And in the parentheses, I have a sort of there. There's a way to get around that. And if we have enough time after the presentation, just remind me and we can kind of talk about that. Models can only be deployed in premium workspace. So if you have, just like what we said, if you develop it in premium, you have to consume it in premium. The models that are created, so let's say you have 5 premium workspaces. And if you develop the model in premium workspace number 1, it has to be consumed. It's only available in premium workspace number 2. You cannot grab a model that's developed in other premium capacity or premium workspace rather. It cannot be used or invoked in desktop, which is kind of different from Azure ML. So in Azure ML, if you develop something in Azure ML, that model can be invoked in Dataflow, or it can also be invoked in desktop. Dataflow, the Power BI AutoML is all Dataflow. It's the 100% Dataflow. You have to use it there. You have to consume it there. You have to develop it there. And it's not exactly AutoML or Azure AutoML, I should say. So it does use Azure AutoML on the backend. So everything that we are going to develop in Power BI is actually using Azure AutoML via ML.NET, but it's not exactly the same. And the main difference being, if you develop something in Azure AutoML, it doesn't care where you use it. You could use Tableau, you could use just your local Python file, Excel, doesn't matter. Whereas in Power BI, if you develop something in Power BI, you have to consume that model in Power BI. Now, whenever somebody hears the word machine learning, or you Google it, what's the first thing that comes in your mind, or what is the first thing that Google shows you? Something like this, which I absolutely cringe whenever I see this. It's either some variation of this. Either it's a robot that's thinking. He kind of have a pensive mood there. Maybe I don't know what he's thinking there. Or it's kind of a brain with electronic circuitry, kind of implying that the ML part of it is something goofy that's going on, and it's all robotic, and it's something that the machine does, as the machine part in machine learning implies. And then, yeah, it does something magic. And we will demystify that, and we'll show you, I'll show you that that's not really the case. And what's our goal here? When we say we are using machine learning, or we are creating machine learning models, or develop a product that's based on machine learning, what exactly are we doing? At a higher level, we have something happening. So on the left side of the screen, we have something called as a true function. And true function meaning it could be a physical phenomena, it could be something that is going on in your business. And with machine learning, our hope is that we will be able to create a mathematical model of what's happening, and create a representation of that real phenomena using these algorithms and using the data that we have. Now, what this true function is, what's this actual phenomena is, we can explain it, we kind of talk about it, and we have an intuitive understanding of it, or sometimes we don't even have an understanding of it, but it is there. And we never know what that true function is. So with machine learning, we gather a whole lot of data. And why do we need a whole lot of data? Because we're trying to gather as much signal and as much as possible all about that true function, and then create a representation of it. And if you see the difference between the two, the true function is kind of a nice smooth line, and the representation is a dotted line with edges rather than smooth. And the reason for that is we can never go to that true function. So there's always going to be some sort of an error. And that is what, when we say we are developing this machine learning model, that's what we are doing. We create this representation of the true function, and then we assess via the model, the data that we have gathered, that whether are we close to that true function or not? Are we close to that what's really is happening? Are we close to that or not? And whenever we are close to that, we have some sort of a threshold, right? We have some sort of a cutoff or a metric that tells us, yeah, we are close enough. And then that's what we call as, okay, the machine learning model has been developed, and then we can represent that true function. So what is the difference between machine learning and AutoML? As we just discussed, our goal is use algorithms and lots of algorithms, and then we use the data. And data here, in machine learning people, they like to call features, which we data analysts or BAs, we call them as columns. So you have your semantic layer, you have your semantic enterprise data, which has lots of different columns in a tabular data. And you gather all these columns, you don't know if they're going to represent that true function or not. You run it through different algorithms and create that prediction. So when we say we have created a machine learning model, the highlighted over here is function. We are creating that function. And what you have to keep in mind, as I said earlier, we don't know that what the original function is, but we try to gather the data, which means we are just sampling from the overall universe of the data. We are just getting some sample of that data. So machine learning model not only depends on your algorithms that you use, but it also relies, or the assumption is that we have sampled from that data, or we have big enough data that represents that function. Okay, and that's what our goal is, and it involves a lot of applied statistics. And the difference, in case you're wondering, what is the difference between statistics and machine learning? Statistics was developed because back in the days they did not have enough data. So they developed all these statistical algorithms so that we can inference, we can get something meaningful out of that data, small set of data, so that they can get something out of it. So that's what statistics is all about. Statistics is more about inferencing, not predicting, and it typically works with small set of data, small sample size. Data mining, data engineering, and then experimentation. And the reason why I have highlighted experimentation, that's the real key piece that I hope you'll take away from this, that even though we are using AutoML, it will involve a lot of experimentation. Now, we are going to get into a lot of details. Now, this kind of is a simplified version of the overall machine learning process. But is it simple in real life? Well, in real life, when somebody says, a data scientist says that he or she is working on or has created a machine learning process. So let's say, for example, with big companies like Google or Facebook or Uber, Netflix, when they say they are working, they have created a machine learning algorithm to predict something, they are going through a very complex process where they have to gather the data, do all the data munging, and then exploratory data analysis. Then they create the feature store, and then model serving, and lots and lots and lots of things. Now, we, as the users of Power BI, we will never encounter the complexity that those systems will ever have to deal with, or what they deal with. What we work with is typically tabular data, and which is where Power BI is going to help us not go through that entire process and automate the parts of that overall machine learning process, so that you don't have to go through that entire thing. And the reality is, a lot of this process is extremely laborious and extremely manual. And if you watch the ML space right now, the big wave early on was machine learning, right? Then it was like data scientists. Can we develop these models? And now the next wave really is ML ops. So anybody can create a machine learning model, but how do we manage those machine learning models in a centralized fashion? And which is where I think Power BI has a great opportunity here, because it provides you not only the data, but also these machine learning capabilities, and also the platform where everything is managed for you. So if you are a data analyst or somebody, or a data scientist who is not, or maybe a team, just a single data scientist, and don't want to either have the expertise, you don't have the expertise, or the infrastructure to go through that entire process, this is the right fit for you. What's our goal today? The goal is not to create the most accurate model. The goal for us is to create a solution, a business solution. If you are going to use Power BI for business purposes, then it's a business solution. If you're going to use it for some other purposes, maybe you work at NGO or something, then it's still a solution. So we are going to create a machine learning solution that is business focused or your application focused. It is going to be accurate, and we will define what that means. Interpretable, generalizable, manageable, and fair. And all of these things have to happen before you can call it a solution. So if somebody just creates a machine learning model and gives you or tells you it is 99% accurate, then your next follow-up question should be, is it interpretable? And I'll go through each of these terminologies, but it has to be a solution and not just single model. The ML tasks that are involved in Power BI, at least, there are two different machine learning tasks that you can do. Regression, which is predicting a continuous quantity. So that could be a rainfall, or that could be number of cars, or it could be sales, or it could be, for example, my age, which reminds me, I should ask you that since we are going through, we'll be looking at predictions, I want you to take a guess. I've already given my introduction, but take a guess of what my age is. Type it in the chat window, and I'll ask Greg later on what your prediction is. So go ahead. You can look at my blog, anything. The only rule is don't reveal it where you have found that information. Okay. Not because I'm for privacy reasons, but we're running an experiment here. So yeah, do that. Go ahead and do that. And second is classification. Classification is predicting a category, like a cat versus a dog, or customer versus a not a customer, or something that is a category. It could be one category. It could be multiple different categories. I should explain that regression and classification, these are supervised type of machine learning. What that means is we already know what the output is. So we've already gathered the data, and we know what the output looks like. There is another type of machine learning that is unsupervised modeling, or unsupervised machine learning, where we don't know what the output is. And I will give you an example of that as it relates to AutoML. And then forecasting. Now, that is something that Azure AutoML has, but Power BI does not have yet. And I have a feeling that the day Power BI announces, I know they are working on it, that they have forecasting, auto forecasting in AutoML. I think a lot of customers are going to jump into Power BI PPU, because if you go to my blog, I've written extensively about the time series forecasting. I've given lots of presentations on forecasting, and I get at least 3 or 4 different emails from different parts of the world that, hey, how do we create a forecast in Power BI? I've read your blog, and how do I do it? And so I know there's a significant demand for forecasting for obvious reasons, but hopefully Power BI will release it soon. What we are going to do today is look at, so I had prepared 2 different modeling examples, regression and classification. We will look at classification if we have enough time, which I don't think we will, but if we have enough time, we'll go through regression, but the steps that we're going to walk through are going to be exactly the same with some minor differences, but we'll go through classification. And also classification, because in business setting, it's my experience that classification is much more applicable, and also regression can be turned into classification. For example, one I guess problem that I work in my company is we want to predict what is the delivery time to a customer, for example, because we want to track if the order is going to be late or not. So initially started working on that, and I can predict that, okay, my delivery time is going to be, let's say, 90 days from the date of purchase. But I can very easily turn that into a classification problem to say, if my standard delivery time is 8 weeks or whatever, Then if it is above that, then it's a late order. So is it late or not late? So you can turn a regression problem into a classification problem like that. So you will find that more practical. The data set that I'm going to use today is real data, bank marketing data, and this is from 2014. So a lot has been written about it. A lot has been, if you Google it, you'll find a lot of different tutorials and things like that. But what I'm going to show you is the as advertised version, as what you see in Google. If you type this one and what you see in there, and or even Power BI themselves, how they advertise AutoML as, and what the reality is. That what are the steps involved when you are creating a machine learning solution that we just talked about that hits all of these things. Is it business focused, accurate, interpretable, generalizable, manageable, and fair? Most of the things that you will see in these tutorials, uh, like Medium for blogs, is it accurate enough or not? But that doesn't really work in real life. Okay, so let's get started with it. I'm going to put it in the chat window, the data that I'm going to use. Let me go over here. So if you have Power BI, AutoML by any chance, let me know, Greg, if you see the chat, the data set here.
Not yet. I see a black screen says the RDP can't find computer.
Okay.
There we go. Okay. It's a yellow brick.
Okay.
Oh, almost there.
Okay. So do you see my? Yeah. Okay. So I put in the chat window, I pasted a link to the data. Okay. So if anybody is curious, you can go ahead and take a look at that one. And then I'm gonna move to Power BI. So this is Power BI, perfect. And then this is my, come on, move over here. Okay, there you go. Okay, so if I go to now Power BI, go to powerbi.com, and then I have workspace. And how do you know a PPU workspace is by this diamond? And I have a bunch of these workspaces now. We're going to try this AutoML demo, which does not have anything yet. So we are starting from scratch. I've already prepared an example, and I am treading on very slippery slope here because we're going to try a lot of different demos. So hopefully everything will work fine. So I am going to create a data set or a data flow rather. So I go to my data flow, create a data flow. I think this shouldn't be anything new to you. And I'm going to put in my URL here, which I've pasted in the chat window. And by the way, don't forget to guess my age because it will make sense later. And then transform the data. So we're going to get the data. And it will show up very soon. One thing that you will notice with PPU is that because we are using dedicated capacity, it's very, very fast, which I love. I wish my company had PPU, but yeah, so far I've really enjoyed it. So what do we have in this data? So this is a bank marketing data from a real Portuguese company. They collected this data, I think, over a span of 2 or 3 years. And we have about 32,000 records. And the columns that we have here are like, they contacted a customer. So this is a marketing data. And they contacted throughout their campaigns, they recorded who did they contact, what the person that they contacted, what did they do, what was their age, and then marital status, and then when they were contacted, what was the bond rate, for example, or what was the employment rate, and then if we had contacted that person previously or not, how long did we speak with them, whether the previous contact with them was successful or not, and things like that. Obviously, this is a pretty clean data, but with Power BI, I was going to start with really messy data and then show you how to create a data set that's going to be useful for machine learning. Trust me, that's one of the hardest things to do, and I didn't want to spend a whole lot of time doing that. So just take my word, when you are creating a machine learning model, pretty much 50 to 60% of your time is going to be spent on just gathering the data. Because think about it, if you have a business problem, nobody is going to come and give you the data. But thankfully, you have Power BI, which means you have access to the whole enterprise data. And all of that data is already, hopefully, you're doing it using Dataflow. My company, I use Dataflow significantly as a kind of a data warehouse solution. But you have access to all this data, so it shouldn't be too difficult for you to put the data together. So the way you would go about doing that is access a lot of different data flows. One cool thing about the premium capacity or using data flows in premium capacities is you can connect or you can create linked entities, meaning you can access a data flow within a data flow, which is kind of cool. If you already have a lot of data, semantic data, then you can just merge the data together, append the data together to create your data set, which is exactly what this company did. So they have all this data, I believe like 22, 24 different columns or so. And at the end of it, they have this column called Y. And what this Y is that whether the campaign with that person was successful or not. Meaning, in this case, this is a bank, and their product, at least for this campaign, was a term deposit, like a CD. And if that person, after they had been contacted, if that person subscribed to that CD or not, subscribed to that whatever that bank product or not. And yeah, so that's the data set. And the goal here, as is typically shown in a lot of these tutorials, is we want to predict this Y column. As I mentioned to you earlier, this is a category, right? So this is no or yes. So we have two categories, no or yes. There could be third as well, yes, no, maybe, or something else. But in this case, we just have yes and no. And we'll close this one and then create a data flow. So we'll call this as our data flow 1, for example, and let's say save and then refresh this. So we should have all the data. So before you create any machine learning model or use Power BI AutoML, you first have to create your data flow. So which is what we are creating here. Shouldn't take more than a minute or so, hopefully. So let's go check it out here. It's still refreshing. Okay, it's done refreshing. Now, if you look for machine learning here, you won't find it, which is kind of confusing to me. I don't know why Power BI does not have this upfront somewhere, but you have to first click on the data flow because you're building your machine learning model with the data flow. And then you have to click on machine learning models, which is right over here. So you click on machine learning models and you are presented with a nice UI. And yes, we want to get started. It will first ask you which table you want to choose, which is this table, and what is your outcome column. In regression, it would be your continuous. In classification, this is all the way at the bottom is my Y. So I'm going to choose that Y. And one thing you should keep track of when you are doing this is kind of go through the list and make sure that Power BI is identifying your data in the right data type format. So my default, I know this data set, so I know that this looks good, then everything is okay. So I click on Y and then say next. Now it will show me what is it that you're trying to do, the task, the machine learning task that we have in front of us. It has already identified for me that it is a binary classification problem. Binary because it is yes or no, so there are only two categories. So it has identified that it is binary classification. You don't have to use that. If you want to select something else, there are three different types: binary classification, general classification, which binary classification is subset of. So general classification is if you have three or more categories, then you can use general classification. For this case, we could use either binary or general classification, doesn't matter. And then regression, which is not applicable to us because it's not a continuous quantity or numeric value. So it is grayed out. So I cannot select that. So I'm going to choose binary classification. And then next it asks me what is your target outcome? What is it that the two categories that you have? Are you interested in one particular category? Is of your interest? So in this case, obviously, yes, because is my category of interest, because that's what I want to predict, if the customer will sign up for the term deposit or not. So I say yes, and then my mismatch label, meaning if it is yes, then what's the other one? That is my known. So I type in no there, and then click on next. And this should take just a couple of seconds. When I do that, it's going to show me all the different columns that I have. And what it's doing here, if you see my screen, it went through all the different columns, kind of just glanced through it, and it tells us, okay, the lone column or the lone feature here, it has low correlation. Just to refresh your memory here from the school, if something has a good correlation, then either positive or negative, then if it increases in X, it increases in Y as well. If it is a negative correlation, it goes like this. If it is no correlation, then it goes straight. There is no correlation. If there is no correlation, we cannot predict a Y using the X. So that's what Power BI did for us. Now, is this correct or not? I'll later show you why you should not rely on this. But right now, again, we're doing this the as advertised version. So we just follow the default settings and then just follow the process. It does that, and model name. Model name is my model 1, for example. And then at the bottom, you can enter the description here, and at the bottom, it is training time that you have to choose, and it goes from 5 minutes to 6 hours. And I think you cannot type it in. I wish you could, but you just have to slide it. And what this is when you are predicting, creating these machine learning models, remember what we had talked about. We go through a lot of different algorithms, the machine learning algorithms, and it will try all of these machine learning algorithms, and then it will see which one makes sense, and then tell us that way, use this model, which is what it's going to do. What you have to keep in mind is this is kind of a max value that you're setting, meaning if you set 2 hours, 120 minutes, doesn't mean that Power BI is going to run it for 2 hours. It could very well take maybe 5 minutes, but it will not exceed 120 minutes if that's what you select. What I'm going to do is slide all the way to the left. By default, it is 2 hours. What I have seen in my experience is that it usually takes about 30 minutes or so. I've never seen it run for hours and hours. Maybe for very, very large data, it might. But even with large data, I've tried more than 100 columns and then millions of rows, and still it wouldn't take more than 45 minutes or so. So we do that, and then we say save and train. Now what Power BI is going to do is it has changes saved. So it is the changes have been saved. And if you go right over here, we have this spinning wheel kind of a thing, which tells us that your data flow and Power BI machine learning model is now being created and data flow is being worked on. If while that is going through the process, you can click on data flow. And then when you click on the data flow, go to machine learning models, and then you will see the model one that we created, kind of a brain about earlier. I don't know why it has to be brain always, but it's a brain. And then type is prediction, and what are the different actions. It says ready, but it's actually not ready. I don't know why it is saying ready. It will be ready. Right now, these two buttons are grayed out, which tells me that it is not ready. The machine learning model is not ready yet. So it is grayed out and it still says ready. I don't know ready for what, but yeah, it is not ready. So we should, wait, and we'll just have to keep looking at this. And whenever it's done, we'll know that our machine learning model is ready. Well, thankfully, I have already gone through that process elsewhere, so we don't have to wait, and we'll come back to this one and then pick it up from there. So let me go to, I think it is the demo version, and it is bank demo. And so I went through the exact same step that I just did, and I have this demo one trained yesterday or a couple of days ago. And when you are done with this, you will see there are three options that you will see here. The first option is retrain the model. Second is view training report. Third is apply ML model. And then there is an ellipsis where it says info, which gives us the information about the model that we had set up. Edit will take you back to the edit mode where you can again specify and go through the same process that we just went through. And then delete, which we don't want to do. So how well has your model done? What is the output of the model? If you want to take a look at that, you will click on this report kind of an icon, which is yeah, view training report. So you will click on that, and then it will flash a Power BI report, and then it's saying checking your training report, and it will spin for a while. It will take another minute or so, and it will give you an error. Now, this is something that I don't know if I'm doing something wrong or if it is Power BI. 100% of the dashboards or the machine learning models that I've created, it will always throw you an error. Yeah, there you go. There was an issue while preparing your report. I don't know why it does that, but it took me a while to figure out how to fix this. So here is how you fix it. You go back, and my model or my machine, my data flow was this bank demo without report. If I go to content, there is this dashboard that it created, or rather report. I keep saying dashboard. We create a report in Power BI, but everyone in my company keeps calling it dashboard, which really confuses me. But we have this report in that is just created with these three lines here, which just tells us that this was just recently created. So I'm going to click on it, and when you click on it, it will show you something. And when you see it for the first time, if you don't, let's see, it says AUC is 87%. Click on the see top predictors here, and then it will show you something really weird. Sex is male, P class is 3, fair is 3. If any of you have worked with the Titanic data set, you will know this is the Titanic data set. So why is Power BI showing me Titanic data set for a data set where I've created my machine learning model using a completely different data set? I think this is their default version. So again, the way you fix that is some glitches in Power BI, which they hopefully they'll fix. The way you fix that is go back to your data set, which had that model, and which is this one. I'm going to go to my schedule refresh and then go to gateway connection. And again, this is one of those tweaks that nowhere is written, but I just know because I've tried it. You have to click on use the gateway, even though this is we are using data flow, we shouldn't be using the data. You have to use that and say Power BI, apply, and then turn it back off, and then apply again, and then go back, and then now refresh your. Was it this one? Yeah, and now refresh it, which shouldn't take more than 10 seconds, and that will get our report ready. So if you're using it for the first time, if you're using AutoML for the first time, I'm 100% sure that you'll be confused by this, but lucky for you, you are here, so you know it. So give it a second. So 94%. So which is intuitively, we still haven't discussed what AUC means, but 94%, well, the number kind of sounds high. So which means whatever we have created is good. Let's take a few. Let's take a look at this. It says the actual is yes. So the actual that we have in the data is yes, and what we predicted also yes. There's 718 total, 6,000 rows. I think this was what used for. Out of those, 718 were predicted correctly. The predicted was yes, but actual was no. It's 6,000, so significantly high. So meaning a customer is not really a customer, or they did not subscribe, but the model is predicting yes, they will subscribe, is significantly high. And then we have some slicers and cost benefit analysis. And then if you go to the second page here, accuracy report, then training details as to about the training. A nice looking chart here that tells us what is the model quality over iterations. A line that is trending upward, so that should mean something is good. And then we are in the good territory here. If you go back to model performance now, and then click on see top predictors, meaning the features that we're looking at, which are the top predictors that help us make the predictions, or that help in making that prediction. So these are the prediction. It doesn't tell us the quantity, what does this bar chart mean, or anything. It just says these are the top predictors. And these are the top predictors here, the column duration, and then number employed, month is May. It's good. So in most cases, this is what you will see, that, okay, we have created a model and it looks cool, very high model performance based on this 94% accuracy or AUC number. So let's go ahead and apply it. And the way you apply that is you'll have to go back to your machine learning model, which is here. Or rather, click on the machine, click on your data flow again. Machine learning model. And why is it not shown here?
Come on, demo gods, you got this.
That is okay. That is still okay. We have that covered. Yeah. So without the reports, I can go to this one, and we can see these two double arrows. It says apply the machine learning model. So I can click on that, and it will ask me where do you want to apply that. And I will choose bank demo because that's the only data flow that I have here. And what do you want to call the output column and what the threshold is. Right now, I'm not going to apply that. We'll do that later. But once what happens after that is once you do that and click on save and apply, it will look at your data, and then it will make sure that you have all the columns that we had specified. and then it will map your machine learning models automatically to that. And then, so even if you have like 50 other columns in your data set, and your machine learning model is built on 20 different columns, it will look for those 20 different columns in your data set, or data flow rather, and then just use those 20 columns and then make the prediction based on those 20 columns. Okay, that's what is going to happen, and we'll look at that later. But just trust me on that. That's how it will work. Now, is there a problem with this approach? Did we create a machine learning model? Yes. Did we create an accurate machine learning model? Probably yes, because we looked at that number, 94%, which should mean something. We're just 6% away from 100%. So, which means if we assume that 100 is that true function, we are 94% of the way there, which is amazing. Did it mean that it will solve our business problem? Maybe, but we don't know that yet. If your VP comes in and if he asks you those questions, you will probably won't be able to answer that. What did this machine learning model do, and how is going to make those predictions? We did look at those top predictors. That duration was the most important factor, followed by a few other columns. So we can say, yeah, this is what the machine learning model is doing to make those predictions. But we still don't have an insight. Right now, the AutoML is creating or outputting this machine learning model, but it is behaving like a black box, which is something that happens a lot. Even in machine learning, even if you're not using AutoML, just using traditional machine learning, it will create an output for you. It will create this nice looking metric and everything for you, but it doesn't give you the insight. And now what we are going to do is we have done the advertised part. Now we are going to focus on how to create a machine learning model the real way that answers all of those questions and then helps you create a business solution. Okay? So let's get into it. The very first thing that whenever you are working with machine learning, doesn't have to be machine learning. We all are data analysts, business analysts, and I think we work much closer to the business than a typical data scientist. Data scientists mostly they're very deeply focused on the data and the computer science and the software engineering part of it. We as data analysts, business analysts, we work much closer to the data. So we understand, first of all, that we have to create a business objective around this. And what is our business objective? I took the liberty to create one for us. And the business objective here is that we have a budget. If you want to create a marketing campaign, our budget is $200,000. And every new customer that we add, our finance department has told us that it adds $1,200 to our bottom line or top line. And the target profit that we are hoping to get out of this marketing campaign, if everything goes well, it has to be, this should be the other way, right? It has to be greater than $100,000. And we have run some estimates, and based on our estimate, it takes our total cost is, let's say, about $8,235 to contact one customer, or to run this campaign per customer. Our cost is $8,235. So, knowing all this information, knowing these business constraints, how do we go from here to figuring out if the model that we just created will work or not? Can we, and which are the customers that we should be targeting? Should we just contact everybody, or knowing that we have only budget of $200,000, who are the customers that we should be prioritizing? And then how do we target them, and when do we target them, which is very important as well. Do we run this campaign throughout the year? Do we run this maybe bi-weekly, or maybe every 2 years, or what has to happen for what are those things that have to happen for our campaign to be successful. So let's take a look at that scenario. So I'm going to go back to that machine learning model that we just created. So let's go to this Azure ML Demo, and then yeah, let's go to Azure ML Demo. And everything is going to work exactly the same way now. The only difference that I'm going to make here is, first of all, what I'm going to do is I'm going to call this, let's say, all data as imported. This is the data that we have imported from our data warehouse, or we have done all the merging and everything in this. In your case, you will have some sort of a date column in here, because enterprise data always has some sort of a date. It is evolving all the time, right? So it is always some data that, okay, this data was collected over a period of 2 years. And when you are going to make the predictions, you will also have some timestamp. So the first thing is you want to make sure that you have that data and that you have that date column here. In this case, we don't have that. So I'm going to create one fictionally by, let's say, I just add an index column here. I just added an index column, has about 32,000 rows. So 32,000 rows. And then I'm going to say enable disable load, and I'm going to create a reference copy out of this. So I go reference 180, and I'm going to call this as my training data. Okay, and for my training purposes, I am going to so training is in machine learning. What is the data that we want to use for creating this model? In our case, what I'm going to do is I'm going to use the 28,000 rows. It could be anything. I'm just picking the 28,000 rows. So less than or equal to, and let's say 28,000 rows, the first 28,000 rows. In your case, it will most likely be, I don't know, if the campaign ended at end of 2019, then you will just say, give me everything that is before the end of 2019. And then we are also going to create what's called as a test set. I go here and then call as, and this is where we will, the machine learning model that we will create it using the training data, but we will test it using the test data. How do we know it is working perfect? Because we will create this test data. And this test data is nothing but that it is going to be, I selected 28,000 over there. So this is going to be greater than or equal to 28,000. So essentially, now we have in this one, we have 28,000 rows, whereas this one has 5,000 rows. The total data set is 32,000. So 32,000, 28 here, and then 5,000 over here. Now, rule number one, when you are creating a machine learning model, is you will never ever look at this test data ever until the very last end. And the reason for that is this is test data represents the future, what's going to happen in the future, and which we don't know when we are creating the machine learning model. If you take a look at your test data, then your conclusions and your insights from that machine learning model will be biased, and you will maybe pick a model that kind of suits to that because you already know what the future looks like. We don't want to do that, so we are never ever going to touch the test data. We're always going to work with the training data. Anything that you do, only test the training data, never ever test it. Okay. So we do that, and then we click on save and close. So again, we just created the two data sets here. We haven't created any machine learning model, nothing of that sort over here. While I'm here, I just want to show you something. If you are in a data flow and if you want to invoke a machine learning model that has already been created, I think it won't work here because that one did not get saved for some reason. But you click on, I'm in the home tab, and in the top right corner, you see this AI Insight, again, that brain thing. And you click on this brain, artificial brain, and then it will look for all the machine learning models that are available for you in that workspace. It won't show me anything that's in another workspace, which is kind of nice that if you want to control who has access to your machine learning models, then that way you can, you can control it over here. So this is where Power BI machine learning, and then I have just this model 1Y that we just created. And when you click on that, it will already map it for you. So if I were to create a if I wanted to create a machine learning model that's already developed, that's how you do it. You do that, select it, and then apply, and it will automatically grab all these columns and create the machine learning model for you. That's not what we're going to do right now. And I'm going to click on save and close. Okay. So this is save and close. Power BI, when you are creating query model one, it has error. Okay. What is the error? Oh, because we are combining the data, because we created the reference quantities, it's giving me that error. You just say continue, and that should go away. I think it may want to click on test data as well. Okay. It just wants to make sure that if you have different privacy settings, you are not combining data from different data flows that have different privacy settings so as not to expose the data unintentionally. So validating queries, which is one of the most annoying things about data flow, which I've heard is going to go away in June. I think they're releasing a fix for that in the June release, which I'm really looking forward to. So that's there. We don't have to wait. So what I'm going to do next is I'm going to launch Power BI, which I have already done. And I am going to go to get data, data flow, and I'm going to connect those two data flows that we just created, the training data flow and the testing data flow, which is already here. So right click and then go there. Okay, so I've already created the training data flow here. Yeah, refresh, go ahead, and then testing data flow. Now, next, what you want to do is the first step here. The first step was creating a business objective, which we already did. The second is understanding the data and understanding the data generation process, which is extremely important. Because remember what we talked about, this whole true function. We assume that we have collected data from this true function, or North Star, what actually is happening. And we very well may have done that, but at the same time, maybe the way we have collected the data could be wrong as well. So you do want to understand what is the data generation process. And in fact, even for my Power BI data models and the data dashboards and everything that I create, that's one of my first questions. It would tell me, how did this data get here? Who enters this data, or who types it in, and all that kind of stuff. How many hands it passes through before it gets to me? So because as you all know, there are quirks with it, and you can get a lot more idea about the data just by following that process. And what I'm going to do is I'm going to turn on you go here, there's a column profile. I'm going to click on column profile, and then it shows you this green bar. Click on the first thing here, for example. Okay, it shows you a nice profile here. And then it says the count is 100, max is 91, min is 2. We know that this we have 28,000 rows, but the profile is actually generated only based on 1,000 rows. And the reason is because profile is 1,000 rows. So if you go down here, column profile, just click on that and say create a profile based on the entire data set. And I select that either top or bottom left here. So select that. Doesn't take a whole lot. And then, yeah, so let's begin with our data profiling phase here. So we have a 28,000 rows. Our min customer is 17. Our max customer age is 98. So there is quite a bit of range. If we look at the age bins here, we have 31, 32, 33, 35. So that's, I guess, one of the first things. So that tells us that we do have a wide range going from 17 to 98. But most of the customers that were contacted are probably in the age bracket of, let's say, 31 to 31 to maybe 40 or 41, 42 or so. The 17 and 98, even if I scroll all the way to the right, I don't see them. So maybe just a couple of them. Now, can we get a customer that is younger than that or maybe older than that? Probably. So we will want to restrict that from happening in our data set here, as well as in the future data. So the first thing I'm going to do is, let's say, anything that is less than or equal to, I don't know, maybe like 100. We want to keep that. Again, the max here is 98. This is just future proofing the data. Okay. Job here, we have lots of 12 different categories for the job. We have admin dot, which I'm guessing is administrator. So we'll just right click this and say replace value. And call that as administrator. Okay. Now, in your case, is this the kind of transformation that you will do? Probably not. I'm just giving you an example that we want to make sure that our data is transformed or in a state where we can make sense of it, as well as future-proof it for future purposes. Also, the thing that you want to keep in mind when you are two essential things that you have to keep in mind when you're doing this. Are there any null values in your column? If there are null values, you will first want to find out why there are null values and fill them appropriately. There are lots of different techniques, and I've in fact created a full blog and I posted a pretty lengthy video that's on my blog as well. So go check it out, different ways of filling the missing values. Statistical methods of filling the missing values. But yeah, and then we'll go through each of these columns now. Like marital status, we have maybe 2 or 3 or 4. Yeah, married, single, divorce, unknown, nothing stands out here. Maybe the unknown part, maybe the original data had a missing value, somebody did not want to disclose, and they are labeling that as unknown. So possibility, we don't know that. Education, probably the same thing. We have expect to have wide variety here. So from illiterate to university degree. We'll go through each of these, for example, and then maybe let's take a look at duration. So this is the duration is the how many, I think this is minutes, how many minutes they speak with that customer on the phone. And the max here is 4,918, which kind of, I don't know, that sounds like a whole, I mean, that's a lot. I mean, yeah, nobody talks that much. So the range here is, the average here is 256, which is still significantly high. Maybe these are minutes, seconds, I don't know. But it's 92, yeah, probably seconds, 92 to 140. But the average is skewed because of this very high number, I think. So maybe we'll try to restrict it 4918. So we'll just say maybe go here and then remove filters. It is less than 4,000, for example. You get the idea. So we go through this entire process, and now we understand the data slightly more. Now, if you look at the features here or the columns here, you will see what type of features these are. So this is NR employed, this particular column here. Yeah, this NR employed right over here. That's the, I think, number of adults employed in that quarter. I don't know if that's number of people employed in the company, but I think this is one of those macroeconomic factors. Eurobond 3, this is from Portugal. So Eurobond 3 is bond rate and things like that. So we have data that's for customers, so customer profile data. Then we have data about the campaign, the previous campaign, and then we have data that indicates the social macroeconomic factors when the campaign was created. So we know a whole lot about the data now than we created the first model. Now what we want to do is create a custom function out of this. And the way you do that, if I go to advanced editor, for example, and if I were to do go here as tab 1 as table, and then get rid of this, and then your tab 1, you replace this basically with tab 1. So that creates a function for you. I'm not going to do that here. And the purpose of, already done it somewhere else, but the purpose of doing that is, let me create that here. Query and then blank query. Come on, okay. And assuming this is our original data set here. We go here, and this is my table name. So I'm going to select training data and say invoke function. So now what we just did is we are importing the data, and then we created this transformation function, which will transform all the data and then create this new transform column for us. And the purpose of doing that is we are essentially creating a pipeline here, because the data that you have in your data flow that you are going to create or have created, it has to be first gotten to a place where it is clean enough or ready enough for it to be used by machine learning. And what does that mean? It means that you have gotten rid of all the outliers that are present. You've gotten rid of the null values that are possibly missing. Fix the quantities, maybe replace some things, add a few things, and maybe fix the column names and things like that. So the future data that you're going to get, it will flow through this exact same transfer function, this transformation function rather, and then create this data for you, transform data for you. And you'll do the exact same thing for your testing data as well. We're not going to take a look at the testing data, but we will create it. And this is my training X, for example. So this is my training X, and then this is X for transform data, and this is my testing X. And we'll go to Power BI now. Power BI now, and then we'll copy that transform function basically. So here, Power BI demo. So this is my imported data that we just imported. This is the function that I just did here. Now, when you create it in desktop, it will ask you for a pull-down menu and everything. whereas in data flow, we'll say null. Nothing to worry about. You just say invoke, and when you say invoke, it will give you an error, and then you just replace this null with your data flow or entity name. So in this case, the training data, and then it will create it. I've already done that, so no need to do that over here. Okay, so we have what have we done so far? We gotten the data, we have transformed the data. We are still not have created the machine learning model yet, and we will not be creating the machine learning model yet either. The next step that we do is, again, we are still in, we'll go back to our, let's say, discard changes and say discard. Give it a second. And we have the, I connect to that transform data again. So I bring in my training X, the data flow that I created. And the purpose of doing that is now we are going to look at and understand this data more before we spend any more time on creating machine learning model. And what better way to do that than using Power BI to do that, right? And one of the best tools that you have available at your disposal is the key influencer. So what I just did here is I started key influencer and my Y, which is my target column. I put it in my analyze, and then I put all the different columns that I have in explain by. Now this is Power BI uses machine learning in the back end again to do this. So it's kind of easy using machine learning to develop a machine learning solution here. But this gives us a lot of insights in a very quick time. If you're curious about how Key Influencer works, head over to my blog. I've given a 1-hour presentation on the inside and out of how Key Influencer works. But what this is telling us is, okay, we are interested in ES. And based on how it has analyzed the data, the duration is number one, or actually, yes. P outcome is the number one factor, duration is the second. P outcome meaning when we contacted that person last time, was that successful or not? Then confidence, consumer confidence, which is the macroeconomic factor. Then down here is age. So if the person is older, then he is more likely to sign up, which is kind of interesting because when we looked at the data, it showed that the range for our most of our customers are within 30 to 40, but they are less likely to buy than customers who are potential customers who are 60 or older. If you look at the target column, which is the Y, yes and no, it has 88% yeses or 88% no, and then only 12% yes. And this is something called as an imbalanced classification problem in machine learning. So if you flip a coin, it's 50-50, right? But if it is significantly skewed, then it is called as imbalance. And this is a hard problem to solve, but thankfully Power BI does that for us. If you were to do it on your own, you'll have to use different algorithms to factor that in and then work that one out. If it is significantly skewed, like 99% and 1, Power BI won't work as well. That's where you'll have to create and handcraft your own model. I worked on similar scenarios, and Power BI doesn't do a whole lot of good job with that one. Another one is, for example, the consumer confidence index and consumer price index. This is the macroeconomic factor that tells us that when the economy when the consumer confidence index is low, meaning maybe perhaps there is an inflation, people are more likely to buy or sign up for a term deposit. Okay. Then we can go to decomposition, which also gives us a lot more about the data. Not going to go through it, but the idea here is that we explore the data quite a bit. We spend more time on the data, and now we have an understanding about the data. That okay, who are our customers? The customers are from 31 to 41, but we also know that compared to that age bracket, 60 plus, they sign up for term deposit more, are more likely to do that than 31 to 41. So does that mean the first campaign that we did probably was wrong? We did not target the right customers? Perhaps. We don't know that yet. We also know that the duration is there, that people were contacted. We also know that macroeconomic factors like inflation and then how many people are employed in the economy, that kind of thing also play a role in people deciding whether they should sign up for the term deposit or not. So, and this is what it means that we developed an insightful and interpretable model from this. So now this is ready. Now we know that we know a lot more about Power BI, this data set, and now this is ready for us to create a machine learning model. So now is the time that we go back to Power BI, right over here, and then we go through the exact same process that we just went through earlier. What we do is, I'm going to edit this one. This was a model that was created. And this time, though, I picked that training X data set, data flow that we created. I'm sorry, the training X data flow, because that's our transformed data. And in this case, I remember when we created the first version, the as advertised version, it said that there is a low correlation between this and that, and don't pick this. Completely disregard that one. Okay? And the reason for that is when you are creating machine learning models, and there are several reasons why you should disregard that. I'm very surprised that Power BI even did that to begin with. First is Power BI is not actually going through your entire data set. It's just profiling the data, and it's creating those correlations based on a few rows of the data set and telling you that there is a low correlation. The correlation is more of a function of linear correlation, meaning if it is something that is highly complex, it still may have correlation, but it may not be linear correlation. So it doesn't say anything about how one factor influences the other. The second or the third factor is what's called as the Simpson's paradox. So let's say, for example, this is for a basketball data set. And this is the log odds of somebody making the basket, and this is the distance on the x-axis. If you look at the first graph here, on an average, it's a flat line. So if we were to run this through Power BI, it would have told us that, hey, just the distance doesn't matter. Don't include that in your model. Whereas when you include and break this log odds ratio by the positions, you'll see the correlation. You will see that as the defender distance increases, the log odds also increase. What this is telling, and this is a very common thing, and it's one of the hardest thing to find out in your data if you have a lot of features. But what this is telling us is you may have overall low correlation, but when you factor in a lot of different categories in your data, there might be significant correlation that you cannot disregard. So the recommendation here is when you are creating, disregard those low correlation prompts that you get in Power BI. Maybe you create two versions. First, include everything, and then create your model. And then second version is don't include do what Power BI is telling you, and then compare the two. See if that is truly the case or not. But just don't do it based on that. So we follow the exact same process again. We do that, and then we retrain the model. And once we have retrained the model, what this is going to do is it's going to follow this process. It's going to create again a training data for you. So this is exactly what you will see in data flow. It will create this training data set and test data set again for you. And then go through the entire machine learning process, and then create the model for you. and then show you the model. And now it is ready for us that is ready for us to use it. And like I'd shown you, the way you would do that is you go to your apply model, and we go to apply model, pick the data set that where you want to apply that. Now, first, we want to apply that to, again, our training data set, okay? Not to the test data set. So we'll apply that to our training data set and say save and apply, and it will create the predictions, which I've already done. And it is right over here. And the way it looks is like something like this. Query. It will create these machine learning. So it says like machine learning training data, machine learning testing data. Now, why we created this testing data twice? Power BI already did that for us. That's more for safeguarding on our purposes. Power BI did it for evaluation purposes, for model validation. Why we are going to do it is for our own safety, to make sure it is, we can apply it for the future data set. So it does that, and then all the way to the right, it will create the column for you. So this is the column that it's created. Yes, is it true or false? Whether the prediction is, if it is false, meaning it is no, and if it is true, then it is yes. And then it also creates a prediction score for us. So with the prediction score should be somewhere around here. And then once you apply that, you close this, and you will create you will start exploring how these predictions were created. And one of the ways you do that is, again, go back to Power BI and then look at this model report that it created. It gives you a nice summary, but now we will try to understand it in more detail. And we have only 20 more minutes left here, but I'll try to cover the important points here, that what you should be looking for in this training report. So this AUC number is area under the curve, and the area that they are talking about here is, actually, let me open it here. You can download this report, by the way, and in fact, I recommend doing that. So area under the curve is nothing but this area that's under the curve. The more area that is covered, the better the model is for you. In this case, it is 94%, like what we had. And the model performance, if we look at it, the top predictors, now it does make sense. If we click on it, then the duration was the number one, and then so on and so forth. Now, the interesting thing about this is this cost benefit analysis. The way you use that cost benefit is, remember the business constraints that we had, that our unit benefit is $1,200. And our budget was $200,000. So we can work it out a couple of different ways. We know the unit cost, we said, was maybe 135, and we can only support maybe, I don't know, 1,000 or 1,500 population based on, or in fact less than that, right? It costs based on that. So, and it creates this benefit profit curve for you. And if we hover over it, it does tell us that if you were to do this, our benefit is, or profit is $114,000. And then it tells us the maximum profit, and this 58 here. So I change the number here for this threshold here. And this is what this is telling us, that, yeah, the model that you have created in this case, there is a case for you that maybe there is a business value to it. You can definitely go ahead and do that. The thing to watch out for, though, is, Power BI now, Power BI Desktop, is this assumes that I'm going to put 1200, for example, here, and then what was it, 135 maybe, and then 1200. I don't know what this works out to, but let's assume that's the case. Maybe it was less than that, $90. 1600, let's say, for example. Yeah, so let's assume we are over here. Okay, if I click on this assumes that the people that we are going to contact, 100% of them will subscribe or will say yes and then sign up for your service, which is absurd, right? There is going to be some conversion rate associated with it, and you can modify that. This Power BI file that I downloaded, the report that I downloaded, it is 100%. It is 100% editable, and you can just go here. And let's say I'm going to assume that it is 60% conversion there. So I put in 60% here. So this was supposed to be, I was working with that. So if we have 100% conversion, then our profit, let's say, is $177,000. If we have 60% conversion, then our profit is going to be much lower than that. And if we have 20% conversion, it's going to be again significant, is even below that. The threshold, the benefit threshold that we had, or the profit threshold that we had. The purpose of showing this is now we had a machine learning model, and now we are blending our business decisions into this. So you can go back to your marketing team and have those discussions. That what is this conversion rate going to be? If we want to have more conversion rate, then shouldn't we increase the budget or not increase the budget? And then can we drive the cost down? And this is where you will see a lot more benefit coming out of these machine learning models and just creating these models. Another thing here is, if I go back, these top predictors, all of these top predictors that have been created here, don't confuse these with the key influencer that we had. These are created, these are called Shapley values or SHAP. And that's, so those are two different things. So don't confuse them with that. So we covered the business aspect of this. We covered the accuracy part of it. The accuracy does not, the 94%, that's actually misleading. And the reason for that is if we had studied how the data was generated, what was the data generation mechanism was correctly, we would have known that the duration column here is actually misleading because the customer agent is going to contact the person. And at the end of the call, they will know if that person is going to sign up or not. And they hang up and they record how many minutes or seconds they talk with that person. So if you see there is a correlation between the two, right? If somebody is going to sign up, then we already know that the duration is going to be significantly high, which for future calls, we don't know what that duration is going to be. So this duration column is actually leaking data into our model. And that's why it's giving us that false accuracy of 94%, which is not accurate. So the step here that we would take next is drop that duration column because that's not what we want. So this is the thing that you should be looking for when you're creating this machine learning model. So drop that column and then create your machine learning model again, which I did. And when I did that, it dropped this AUC down from 93% down to 78%. Now, did we create a more accurate model? If you look at this 94 and 78, probably not. But it is more generalizable. Generalizable meaning we can apply it with confidence to future data, and which is important because the goal is, again, that we want to be able to predict the future. So we want to make sure that it is future proof. So we transform the data correctly. And then we also made sure that it can be applied to the future data correctly. There is no information that's coming into our model that will bias our understanding of this. So we covered, let me go back to this. So we covered over here the business focus part, the accuracy part, the interpretation part that I'll talk about, the generalizability that we just talked about. What we have not talked about is interpretability, and then the fairness in the model. And I'll go over that very quickly here. So when you create a machine learning model, what you always want to understand is where the errors are happening in your model. And the way I know the error is because we already know what, based on the past data, we already know what the outcome was, yes or no, and then we have the prediction, right? And then we can compare. If it is yes and yes, then obviously the machine learning model the right prediction. If it is yes and no, then it is incorrect. That's an error, right? And what I did here was I took out the age column and then plotted the prediction score, that probability, and then what percentage of the predictions had error in it. And then surprisingly, here is x-axis is age again. Red bars indicate the proportion of errors, and what this is showing us is after 60 or above, 60 and above, we have more error in that the machine learning model is creating. So it is making a lot of errors for population of the data, population of our customers that are 60 years and older. Age, just like sex, your marital status, your housing, these are protective classes. Meaning, if we want to create something that's fair, we should not be discriminating against any of those categories. So the model that we have created over here, is it a fair model? Probably not, because the way we are looking at this is if we were to make predictions based on this, we would be more biased towards giving the term deposit or granting the term deposit to younger population than the older population. So this will depend on who your customers are and that kind of stuff. So the solution here would be that maybe we want to gather more data for that section of the population for 60 and older, or perhaps we maybe exclude this altogether from our data set and just focus on that 30 to 60 population, right? And then we just contact people in that data set because that's where we have more accuracy. And then you can go through and then look at a lot of different stuff here to understand how you do that. Now, I promised on Twitter that I'll show the feature that was launched yesterday, that how do you connect your Power BI data set to your Jupyter notebook. And the way you do that, go to my blog post here and then follow this blog. But when you create these machine learning models, you can connect your data set, your Power BI data set, or in Power BI service as well, and then import all your data in Power BI. So that is exactly what I did, and then ran through some machine learning algorithms to understand the structure of the data even more. And then you can now even embed all these dashboards. You have to go to Power BI. If you know Python, you can install Power BI Python client, and it's pretty simple. And you can embed your dashboard that's published in Power BI service. So, for example, this error analysis dashboard that I just showed you, I can go to Power BI client.authentication, authenticate myself, give the group ID, report ID, and embed that in Jupyter Notebook. And then actually it will let me, in fact, extract data out of the visuals as well, which is pretty cool. I can extract the data out of those visuals and do my own analysis on the data to extend on top of what we are already doing in Power BI. So we talked about the fairness, which is important when you are creating any machine learning model. So the accurate model that we created has still a lot of work to be done on it to make sure it is fair. So we created a model that is generalizable. We created a model that is business focused because we looked at all the profile curves, profit profile curves. And then lastly, what I want to show you is the explanation. So when you create the machine learning model in Power BI, one cool thing is it also creates explanations for you. What that means is on top of giving you the prediction, it also tells you how that prediction was made, what factors were taken into consideration for that one particular customer or for that one particular observation, which is pretty cool because the predictors that we looked at were at a global level, meaning taken all the data set, which were the columns that were important. This is telling us how the predictions are made for each of the observations. And then you can plug those out, for example. And let me go right here. And you can plug those out and then create a prediction with the final model that you create or the prediction that you give. You can include that. So for example, what I did here was this is a list of assuming we are going through this campaign and we are, this is each one of these rows is my customer. What is the model's prediction was? What is my score? And when I click on it, it also tells me what were the contributing factors. The contributing factor for this person was economy. Campaign did not play as much role. And then distribution of that. So the number of people employed in the economy contributed to that. If I go to the next one, for this person, yeah, economy as well. Let's go through a couple of these. I can, in fact, segment the customers and say, I want to look at people who make decisions based on their profile. Okay, so for example, this person over here, profile, his job contributed to, it doesn't make any sense here because the student, his job is student, but it contributed to making that decision, for making that prediction rather. But this is great, right? We know that the prediction was made. It also tells us that what were the factors that were used to make that prediction. And if the person, you are the campaign manager for this, you will look at this and say, this does not make any sense. The job for that person is student. He is single, and then he graduated from high school. So does that prediction make sense or not? Even though the model says so, probably does not. So which means that you can actually go through this even more and only target the customers that make sense to you. And you can profile the customers as well. Okay, who are the people who will respond to the campaign when the economy is going down or the inflation is very high? Because one of the factors that we wanted to look at was, when should we run this campaign? And the answer to that would be, it depends. If the customer is more worried about the economy and then protecting their assets and things like that, then let's target the customers based on the predictions who will respond to that. Maybe there are customers who are insensitive to that. In that case, maybe we look at the profile of the customer, and then those are the customers that maybe throughout the year we can, for a period of time, we can contact them, or things like that. So this gives us a lot more about the data, a lot more about the customers, a lot more about the predictions that are made than the first time when we created the machine learning model. And that is exactly what I mean when I said that it has to be a solution and not just a model. Let me see if there are things that I should. Yeah, and then overall, the AutoML process, I know it may sound like when I explain this, it's a lot more complicated, but it is not. It is all logical thought process as to how you create this model. If you keep the 4 or 5 things that I told you about generalizability, about making it fair and things like that, Rest of it is just understanding and then playing with the data and then getting it done. So the overall process looks like we have the data, we transform it, create two data sets out of it, training and test. We run the AutoML on it, right? And then it spits out what model is best for us. So the future data that we get, we run it through that same transformation pipeline, get the transform data, and then we compare it with the training. And that's one thing that you have to keep in mind, that the data that we use for our training, the future predictions we have to make sure are also based on the future data has to look like your training data. So let's say, for example, we are in pandemic, right? And right now the economic factors and right now the job conditions and a lot of different things are significantly different from how they were, let's say, 2 years ago. So the model that was created 2 years ago, can we apply that during the current pandemic phase? No, because we did not have the data. The model was created before the pandemic, and the data has significantly changed since then. This is called as a concept drift or data drift in machine learning. But now, so what is the solution for that? Well, you'll have to gather more data and train your machine learning model on your data that represents what the new reality is, and then put it in production. In this case, my advice would be, no, don't just retrain your previously developed model, create a new one altogether, and then put it in production. So that's how you do that. And then monitor your explanations, and then monitor your predictions as well. So if you see over a period of time your accuracy score going down, and it will go down, or it fluctuates significantly, then that's also an indication that maybe you need to retrain your model again. Or if the explanations start making no sense at all, then that is also a cue for you that the explanations don't make sense. It's creating a model, it's giving me an output, but maybe it's time for me to retrain my model again. So we have 1 minute left here. I know we went through a whole lot of stuff. So if you have any questions, let me know. By the way, the reason why,
before we have so many people asking you questions, because this chat has been pretty active. I think you can see if everybody wants to join me in just going off mute, really giving Sandeep a round of applause. I mean, wow, you went so deep, so wide.
Thanks.
I don't know if you saw the chat, but yes, I mean, it's so many points. We were both impressed, and there's a lot of questions. Did you have anything more before we kind of get to Q&A?
Yeah, so the reason why I asked about before the presentation or during the presentation about my age was because I was going to explain how the machine learning model kind of works, and I can explain that better if we look at this thing over here. So when you create the model, it's actually not one single model. It is a model that has, I don't know, what, 8 or 9, 10 different models, and this is called as an ensemble model. And it is getting predictions from each of these models, and then at an aggregate level, making the prediction. So my hope was that I would ask you what my age is, and then if it applies correctly, we can get age from each of your predictions, and if we average that out, you should be able to guess my correct age, or at least get close to it, which would essentially what this thing is doing. So, okay, but we can go to the questions.
Sandeep, so are you doing the ensemble in the Jupyter Notebook then?
So in Power BI is doing that for us. Now, when I work on a machine learning model, I do it myself on the side, like I showed you. I can import all the data set, be it in Power BI desktop or in Power BI service, and then create my machine learning model from there. So that gives me a good baseline, right? Because now if I create it in outside of Power BI and then make the predictions, and if Power BI is doing the exact same thing, that tells me that, okay, I should why do it in Python or Jupyter Notebook if Power BI is able to do the same thing.
Yeah, but it had only regression and classification, nothing else.
Yeah, and as I said, it does regression and classification. So ensemble modeling applies to both classification and regression. Ensembling is just a way of ensemble, as the name suggests, and there are two types of ensembles: boosting and bagging. And all it does is, depending on your data and the type of problem you're trying to solve, it will aggregate those predictions and give it to you. The other portion, which is the unsupervised learning, and I kind of showed that, but we did not have enough time to go over that, is this. So this is the what's called as a PCA, principal component analysis. And this is something, again, to understand the structure of the data. Right? Okay,
We
what is
can't
this?
see your screen.
I can see the screen. Can you not see
it?
Yeah.
Oh, you can? No,
Yeah.
I can't for some reason.
Yeah, so what this is showing me is the features. So for example, number of people employed, the bond rate, consumer price index. There is a section of the customers who prefer that. And this is another cluster over here who respond more to the campaign, which is exactly what we saw in our predictions as well. So it all makes intuitive sense how this model is making all these predictions.
You mentioned that you have this report somewhere on your website.
The report, meaning this Jupyter Notebook?
No, like this Power BI.
No. Yeah. So when you go to Power BI, when you create the Power BI, let me show you. When you create the Power BI machine learning model, so let's go right over here, and then you go to machine learning models, and then you click on this report, view training report, and then it will generate the report for you. So this is all Power BI, and then you can download that report. So you download that report and you can open it in your desktop file, which I highly recommend because there is a ton of stuff there that if you're a machine learning geek, that you will completely appreciate. And I'm really kudos to Power BI for providing all those details here.
So, but this specific model isn't somewhere downloaded on your blog or something, is it?
No, I'll do that. So if you are curious about this, if you go to my blog, so that was another reason why I picked this particular particular case was if I go to powerbi.com and then scroll down. So first is this, so operationalizing machine learning models with Azure ML and Power BI. So I walked through this exact same data set in this, and also in a lot more detail in, if you go creating machine learning model interpretability using Azure ML. And this is a lot more detail than what you would like perhaps. But yeah, you can look at that and yeah, you should be able to follow along in there.
That's great. I see Alex has his hand raised. Alex, do you want to come off mute?
Oh, certainly. Thank you, Greg. Sandeep, just in love with the presentation. It's always incredible to watch this. So I think a lot of us are probably like the self-service journey, right, into like the deep enterprise modeling, especially looking at it here within kind of the machine learning context. Mm-hmm. You're almost doing it in reverse because you're like an expert machine learning and you're like, oh, I'm going to go backwards into kind of this point and click. Can you talk about that transition, the things where you tested and like where you feel like confidence for like, hey, some of the deep ML stuff, they've actually simplified, or some areas where you're like, there's a little caution here, just because what I saw in the chat with people like, this looks great, but it could also be dangerous if you don't necessarily know what you're doing.
Yeah, and I think that's where Power BI has, and I've communicated that with the Power BI team as well. There's these features that they create are incredibly powerful, but the documentation is significantly lacking. And my hope is that with Alex, now I have your ear here, if we have more documentation around all of these things, it will help those people who are not maybe as familiar with machine learning and all these statistical concepts and all the things that have to be taken into consideration. It is not so much, they don't need the data analyst and the business analyst. They don't necessarily need to understand the technical minutiae here, but at least, these are the best practices, like what we have for data flows, right? We have a ton of things around Power Query. We have a ton of things about data modeling and data visualization, but all these cool machine learning and AI features that Power BI, the team is creating, would be really, really important and significantly helpful if they create the content around that as well. And those of you who are interested in this, MS Learn is probably the best way for you to start. There are lots and lots of content out there on MS Learn, be it learning Python, be it Azure machine learning, or be it just using Power BI and things like that. So yeah, and then when you are learning something like this, like machine learning models and stuff like that, try to understand it from not so much from the technical point of view, like the math, and if you can do that, cool. But at least understanding it from intuitive sense that, okay, what if this happens? Then what is it going to do? And I think we as data analysts and business analysts, we kind of already do that. We play with the data a lot. So, break things, take a look at what works, what doesn't work. And yeah, I think, it's not that complicated thing once you know what you're doing.
Love the commentary, and I'll add Raymond's comment here in the chat just because it feels very like it resonates to me. It's the democratization of machine learning, but us citizens of data don't know enough to safely participate. So I'm wholly with you on the Microsoft Docs. If you feel like, hey, your blog is leading the charge, I'm screaming it from the microphone on the highest peak of the mountain. But everyone needs to also kind of leverage Sandeep's voice where he says, we need more, we need more, we need more. I always call him the AI Insights guy for this exact session, this reason. I just love it. Thank you.
Thank you.
Seriously, Sandeep, thanks for being such a trailblazer in this arena. As I said, I just don't feel like most organizations are taking enough advantage of this to be kind of joining in that voice. So kind of good to have you leading the charge.
Sure. Thank you.
I know we're close to time, but I also know everybody probably has more questions. If you want to raise your hand or kind of go off mute, we can spend a couple more minutes together. If you'll like. Yes, Sandeep, you are now a Portland trailblazer. Sure.
Yeah, I look forward to attending your next month's session for sure, and then hopefully in person in the future.
Oh, absolutely. Thank you. All right. Well, if I don't see any more questions, I know it's late in Chicago. Yeah. So maybe one more time, for those that want to go off me, let's give Sandeep another round of applause. Just thank you for the long,
appreciate it. Thank you very much for the opportunity.
In-depth presentation.